Right. Hello, everyone. This is Rahul. So, I'm going to be a part of your CCNA journey. So, basically, I have around 14 years of experience in network domain. So, we'll be going through all the CCNA stuff in this journey. So, I just wanted to know before we start off, just wanted to know if somebody in this group already know about CCNA, so they are trying to refresh their CCNA knowledge, or is everyone unaware of what is CCNA or what is it for?
Hello, Mr. Rahul. Askar is with you.
Yes, Oscar.
Today I done my CCNA on 2005,
Okay,
but I don't have any hands-on experience in CCNA. My experience on system server side and help desk support side. So
got
I
you.
just joined to refresh my knowledge in CCNA. Actually.
Got you. Okay, so just this question was just to make sure uh, how many of you know CCNA and to what level we need an explanation on CCNA, right? So I'm going to be explaining you all the basics, everything regarding CCNA. Just to reiterate some concepts. So there are some of the important concepts, as you know. So we need to go over it again and again. So just wanted to make sure if those people who does not understand networking is in this group, then they need those concepts to be reiterated again and again. So just wanted to make sure. Anyway, okay. Let me go ahead and share my screen. Let me know when you can see my screen. Can you guys see my screen?
Yes, sir.
Okay. All right. So I mean, I know by now you would have actually served about what does CCNA stands for. It stands for Cisco Certified Network Associate, right? Network Associate. So basically, what does CCNA consist of? So basically, what we have here is the basic knowledge of networking, right? We know that in CCNA, we have, I mean, in networking, for example, so you have a computer here, you have a computer at the other end, you have some of the devices. Guys, let's go on mute. Let's everyone go on mute. Let me see if anybody is on. Wait, wait. All right. All right. So we know that we have two computers or a computer and a server talking to each other. In the middle, you also know that there are many networking devices. Let's say a router. For those who don't know, the router is represented in a networking terminology in this way, right? A router is represented in this way. And we have some switches, which is represented in this way in networking terminology. We have firewalls, right? Many networking devices. Now, you already know how the PC or a computer, the computer that you are in front of, generates data. For example, let's say you typed http google.com, right? The computer knows that it needs to go to google.com, right? Google.com has an IP address, let's say 8888. Your computer has an IP address, let's say 1111. And your request is for the recent score updates. So the data which goes to the router from the computer, which goes to the router or any device or a switch, maybe whichever you have connected to the computer. How does this data go forward and reach that Google server? Right? That is all about networking. So we have to make sure that our data which is traveling inside the network is made to travel to the appropriate server. And how do you make it travel? By the connectivity. I know you have connected many cables, right? You might have connected cables between the network devices from one computer to router, switch, server, right? You would have connected cables. Just by connecting cables, it will never go on its own, right? We need to tell the router, we need to tell the switch, if you get a data, if you get some traffic, how to forward it, right? That is all about networking. We do the connectivity through the wires, right? We connect the equipments, but just by connecting the equipments, the data doesn't travel on its own. We have to tell each and every device in between that if so and so packet comes to you or so and so data comes to you. What is data? Data for us is like information, right? Data for us is a piece of information for us. But for the computer, for the switches, for the routers, the data is in the form of ones and zeros, binary. Ones and zeros are called as binary bits. I think we know this, right? Because everybody has an internet connection. They know what speed they are operating on. 10 Mbps, 16 Mbps, 100 Mbps, right? They know what is bits. Inside this connection, how does the data flow? That is what we are trying to understand, basic knowledge of CCNA, how to make it work, how to make the connectivity that we have done work appropriately. So that is our motto. Now, just by that, I would like to actually introduce different concepts in CCNA that we have. In CCNA, I would actually, on the first part, would be giving an introduction. Introduction would be basically a small part like what is networking, how do you form a network, or what is called as a network, how does network interact with each other. This is what we are learning. Second thing that we are learning is the fundamentals. Fundamental means, you know that even if you have to study history, even if you have to study mathematics, there are certain rules, right? The plus symbol performs addition, the minus symbol performs subtraction, right? There are certain rules of every operator. Similarly, in networking, we have certain rules. Rules are known as protocols, right? They are known as protocols, set of rules, right? We will go over the fundamentals, which are our basic strength, to form or make the networks work together, right? So in the third part, we will be looking at network access. Now you might be thinking, what is access? I still don't know what is network. Now we are talking about network access. Every person or a user sitting in front of the computer, he is a edge, right? He is a edge. That is why we call them as end user. Because after user, you are not connecting the user to anything, right? The user is the last man or a human who is actually interacting with your network, right? So he is the end of the network. So where is this computer? So basically this computer is the edge device. This is a human. Now in the network devices world, which is the edge network that we have, which is the edge device that we have, it is always the computer. Computer is connected to switches. Now, why is computer connected to switches? We'll go, we'll go step by step, one by one. Okay. I'll tell you why is computer connected to switches. But a computers often you see connected to the switches. This is known as access because through your computer, you are trying to access the network, right? So this is the first point to access any network or network device. That is why this whole thing is known as network access. How to access the network? So basically, you know English. By access, you mean to use that, right? How to use a network. Who is the first point who is using the network? This guy, computers. So basically, we'll deal with in network access chapter, we'll deal with how we are accessing the network, right? How we are going inside the network. The fourth thing that we are going through in this is IP connectivity. Now, what is IP connectivity? Obviously, now everybody knows every device has an IP address. Every computer has an IP address. You know that, right? Every computer has an IP address. How do you connect from one IP to another IP, right? How do you talk between different IP address? That is what we are going to study in IP connectivity, right? Next, we have IP services. There are different types of services that our IP. Now, basically, what is an IP? Is it just an IP address? Yes, it is an IP address, but along with the IP address, it also provides some more things, right? Like services. What are the services? DHCP, SNMP. These are all different protocols that we'll study in CCNA IP services. Now, don't worry about the technical terms that I'm talking here. It is not very important as of now, but when we go on through those step by step, by the time I reach DHCP, you will know and you will remember what is DHCP or SNMP. You will remember those. Okay. The next thing we're going to talk about is security. Okay. I have implemented the network. I have connected the network from one to another. Okay. As you said, switch, router, another computer. Now, what do I do to secure them? Because only me and my team have to access them. So we'll also concentrate on security fundamentals, right? That will also be discussed. Moving on. Let me take, okay. 7. Management. Now, what is management? Basically, I brought I bought a device from a shop. I can't be every time sitting in front of the device or a router. I am sitting somewhere in the office. I have to manage this, configure this, right? How do we manage and configure our network which is connected together? That is called management. After management, we also have some parts which deals with design. Once you know about how switch works, how router works, how a PC works, how a firewall works, you have to know where should you use the switch, where should you use the router. Using a router is good, or which end of router can I use, high end router or a low end router? Where should I use high end router, low end router? High end switch, low end switch. Where should I use them? How should I design my network so that I can design it in an optimal way? For example, we know that we can't take every device which is of high end, right? Even if you wish to take, maybe, let's say, phones, Android phones, or any phone that you like. Let's say you have 12 users in your house, 12 family members. You know to operate, you daily read. There are four people who daily read and operate and invest in the share market, so they buy a high-end phones. But there are people who don't know how to actually interact with the Android OS or Apple OS. So you buy basic phones for them just to make a call or send a normal message, right? This is how you design your way, right? That is about the network design that we're going to learn, where to use which devices and which provides actually optimum functions of the network, right? After all that, we have a newly introduced concepts like automation. How to automate the network, right? And what is programming a network, right? Programmability. Please excuse my handwriting, right? Automation and programmability. So these are the things actually we'll be going through in our CCNA training, right? Any doubts you have in the topics that we are going to discuss, or can we get started?
Yes, sir, we can get started.
Awesome. All right. So the first thing I would like to start off is with the basic introduction. Now, why do you need to know networking? As I told you, in networking, we have many devices, networking devices, right? You can sit at home, you have a computer. Your brother has a computer in a different room. Your friend has a computer in his house. You're trying to play a game which involves multiple users. You should all be connected. You should all be connected with each other, right? So to have that connectivity, we need to establish connectivity between us. This is called as a network, where a set of devices connected together forms a network. It can be network as big as the internet or a small home network that you have at home, right? The devices, networking devices, which are capable of processing data and forwarding data, the set of those devices connected together form your network, right? So the key thing in the network is, if we have to stay connected, or if we want to share something to anybody, first of all, we have to guarantee the connectivity between us. Once we have the connectivity between us, once we have a network established between us, then we can share anything, right? We can work together, right? It becomes easier to interpret, to converse for any conversation between each other. Having said that, in the previous olden days, we had a computer. So one computer connected to another computer, they could share the data. The data was all fine. It was getting shared between computers. Now there happened a problem. Excuse me, guys. Now there came another guy, even I got a computer. Now they were connected to each other. There was no second port on the computer. As you can see, your computer has very less ports, right? Either one or two, right? They were not able to connect this third guy. What if there were some more with computers? What do we do? How to actually share the data between them? Put it in a floppy, hard disk, give it to that guy. That's okay. He will have the information with him. But what if I make some changes on the information? Again, I have to put it in the floppy, hard disk, give it to him. But it was not scalable. What do you mean by scalable? As and when you grow up, as and when the number increases, this was not fitting or it was not suitable to the environment, right? So there came the invention of centralized devices. For example, invent something known as a hub. Hub is a central device. Everyone just connect to the hub. I know you have a port. Just connect to the hub. Through hub, you can talk to this guy. Through hub, you can talk to this guy. Through hub, you can talk to this guy. Right? So this hub was the first invention. It is known as layer 1 device. I'll tell you what are these layers, right? As and when we go forward, I'll tell you what are these layers. But remember that there was something called as a hub. How did it look? It was just a box, okay? And it had many ports in it. You could have got a 48 port hub, 16 port hub, right? 24 port hub. Depends on the standard manufacturer, right? So this was actually a central device and it was a very good invention. Now we can communicate easily, even though we have just one port on our PC, we can communicate with all the devices that are connected to the hub. Now, okay, hub was good, doing good, but there was a problem with the hub. The problem is, now I send any data to one port of the hub. Let's say this is port number 1. The problem with the hub is any data that it was sent to any port, it would actually send it to all other ports. Right? It would go here, it would go here, it would go here. So basically, in networking terms, it is known as broadcasting, right? Means, what is a broadcast? Means I just shout and everybody listens to it, right? In networking world, when you talk about communication, there are 3 types of communication. One is unicast. Now I pick a guy from this group and I just talk to him alone. Unicast, one-to-one. One device is talking to another. Unicast communication. Next, we have multicast. I'll tell you about the multicast. Third one, broadcast. What is a broadcast? You just stand in the middle of the crowd and shout. Everybody hears it. That is a broadcast. Now, what is a multicast? Now, I only talk to a group of people. Not everybody, not a single person, but a group. Let's say in your office, you are in the monitoring group, network monitoring group. So if an email is sent, only the monitoring people will get it, not the HR, not other guys, right? So it is only to a group of people. That is known as multicast. So these are the three types of communication that we have in the network, right? You don't need to remember it anyways. You will be going through it again and again. Now, the hub's problem was it used to broadcast it. Broadcast it means if I get on one port, I will not send back the data on this port. No, but instead I will send to all the ports I have. So if it has 48 ports, yes, I will send to all 48 ports. Okay. You send it to 48 ports, not a problem. There is a computer connected here. It does not need the information. This computer does not need the information, right? This computer does not need the information. This does not need the information. Only this needs the information. But still, I'm going to send it to everybody. Is there a disadvantage in this? Yes, there is a disadvantage in this. At the same time, this guy also wants to talk to this guy. But in this 2 liter, just assume that this is a wire connected to the computer from the hub. This is a wire. Which is a wire? I'm talking about this one. This is a wire connected to computer via hub. This wire can hold, let's say pipe. It can hold 2 liters. Right? 2 liters. Now, this is also a wire which can hold 2 liters. This is also 2 liters, right? Now, the information, the unwanted data that is coming in is already filled this pipe. Now, there is a legitimate information, the legal information which has to be sent from computer B to computer A is not able to go through because of this unwanted traffic. Because the hub is sending it to everybody, this guy's pipe is just busy in, having unwanted data. This guy's data is not able to go inside this pipe as of now. Right? So that became a problem, kind of problem. It's, the hub's nature of broadcasting it to everybody is eating up all the bandwidth. In technical terms, we talk or we mention that as a bandwidth. Bandwidth is the amount of data that can be handled by a wire or a physical connection, right? Or a port. So that's the reason they decided we have to come over it. We have to go over it. We have to do something. I don't want it to broadcast to everybody. If I send it to this guy, why not only this guy receive it? Right? So they were thinking of that, and all of a sudden, eventually, not all of a sudden, eventually, what they did, they invented another device known as switch. Now, switch was an intelligent device. We no longer use hubs, right? Hub is gone. We only use switches now. Now, switch is also like hub. It is a centralized device for communication. It is a centralized point for communication for all the computers. We need some central point for all our computers to get connected to each other, right? So, switch is an intelligent device. What switch would do is when this guy sends information to this guy, it would actually see, based on the information, it would see who is sending it to who. Then it would only forward it to that particular computer. So they made it. Oh my. Okay. Sorry about that. I think somebody unmuted. No worries. So they made it a little intelligent device where it could read what is the source address, what is the destination address. So if this is A and this is B, this is C and this is D, the information which is coming like 1010 from A, the information was put in an envelope, just like how you write a letter and you put it in an envelope and say from address and to address. Just like that, it would say from I am A is sending and I want to send it to B. This switch could read that information. It could read that information, and if it is B, then it would send it to only B. Right? So that is why we call switch as an intelligent device. It can make decisions. Right? Now, the thing is, what is this? This is the address that every source will add before sending its data. Now, if you are typing google.com on your computer, the server is here. The server also wants to know where should I reply, right? If you don't put your from address and to address, the server doesn't know what is the recent score. What is the score? The server should reply. So to reply, the server should know where this device is, what is its IP address, or what is its, area, which computer it is. It has to know. So all the devices which send the data always add this from and to, just like how you write your letter and add from and to addresses. Hope the concept is clear. Right? Now, let's actually discuss about, now once you know why the switch was invented, once you know we have a switch invented, then you should be little okay, there is some device which can actually, read the contents. Means, does it read the data inside it? No, it will not read the data inside it. It will just read what is the source and destination, just like your postman. Your postman does not open the letter, right? He does not open the letter and see what letter you have written, right? What is the content inside your letter? He just sees from where to where I have to deliver this letter. That is the job of the postman. Similarly, the switch is also more like a device which is acting as a postman. It is only reading the source and destination, but not the data inside it. Now, we will actually look into who adds this. How does it get added? For it to get added, what are the rules that we follow inside networking? Now, in networking, for example, when we talk about networking and network fundamentals, the major thing that you have to learn or that should be in your mind always is OSI model, Open System Interconnect. Open System Interconnect Model, OSI model. What does this model actually tells us? It tells us when you have to communicate between two devices in the network, how should you actually send the data, and on the data, what are the envelopes, from and to envelopes that you need to add. These envelopes in the networking world are known as headers. Why it is called as a header? Because it is in the outer layer. It is a header. Seeing at the header, the devices will see if it is the address is them or it is other devices, right? They are called as headers. Now this model is what? It is the rules, regulations, right? It has many protocols. What are protocols? Protocols are nothing but set of rules. Okay, OSI model has set of rules. In those set of rules, what does it say? It actually says how these two has to communicate between each other. Now, just if I say rule number 1, rule number 2, rule number 3 up to 150, it is very difficult and it is a hard task for any network engineer to go over the rules and also memorize it every time, right? So they are divided into layers, right? Set of rules. In this layer, you have to follow this rule. In this layer, you have to follow this rule. There are set of layers. Set of layers, application layer. The first layer, or let's say, let's go from the physical layer. What is a physical layer? Physical layer is this one, the cable that you connect between two devices. That consists of physical layer. Now, why it is called as a physical layer? Because everything that consists of something that you can see, that you can touch, is a physical layer. Now, okay, why did they form something known as physical layer? Because it consists of certain rules. This switch can be made from Aruba. This switch can be made by Cisco. This switch can be made by HP. But all of them have to follow this physical layer rules. Only then any vendor, Cisco, different vendors like Cisco, HP, Aruba, they can all communicate between each other. So if I say that my phone uses Android, this phone uses, what is that? iOS, right? Another phone uses another OS. means they are not compatible. If they are not compatible with each other, they cannot communicate with each other. My port size is this one, you know, it has radius of so and so. My port size is this much. You have to connect a bigger cable. Inside the cable, I'll have 8 wires. Some will say I'll have 16 wires. Some will say I have 20 wires inside this physical cable. Then if each vendor makes his own way of manufacture, he manufactures it in its own way, then the communication between different vendors is not possible. Cisco only should communicate with their devices, Aruba with only their devices, right? Then nobody else will communicate between each other. So that's the reason they formed a standard set of rules, set of protocols. They formed a standard, right? They decided, no, this will be actually defined in a standard. What you have to use in which layer, right? When it comes to the physical layer, what are the rules? See, you have to have a RJ45 cable. Now, what is an RJ45 cable? The same cable that you connect to your Wi-Fi adapter, right? Sometimes the Wi-Fi is not working. You're not able to connect to the Wi-Fi, you know, you're not getting the network. They would have given you a cable also. You can connect to that Wi-Fi modem. This is a Wi-Fi modem in your house. You can connect through the cable. The cable is nothing but Ethernet cable, RJ45. So the physical layer defines that Ethernet cable, which is also known as RJ45 cable, should be used to connect different devices. If you need high speed, then you can use optics, fiber cables, fiber optics, fibers, right? In the fiber also we have a standard. So and so fiber can be used between the devices. So this is all the rules defined in the physical layer for physical connectivity, right? This port that we connect should be so and so speed supported, so and so speed supported. If this port is supporting 1000, this port is supporting only 10, then it cannot send all the 1000 in this wire because this can handle only 10. So they both will negotiate and it will be sending only 10 because the receiver can handle only 10. So all these rules, physical, whatever physical layers or physical things that we can see, it's all defined in this physical layer, right? This is the layer 1 of your OSI model. Layer 1, we call it as layer 1. Let me write it here. This is known as layer 1. Layer 1 is also known as physical layer. And what does in the cable, what does travel? Your bits 10, 10, 10, right? Okay, how does it travel? Can I push 10 inside it? So basically, you have two computers. Let's say we have two devices connected to each other, not computers, maybe switch or computer. Now, this cable is made up of 4 pairs of wire, right? First pair, second pair, third pair, fourth pair. Okay, I'll use this as fourth pair. In the last pair, what happens? They form a loop. So this is your cable. they form a loop. Loop in the sense, whatever goes, comes back. Right? Whatever goes, comes back. That way. Now, when this is connected to electrical, given an electrical power, this is connected to electric power, the electricity flows through this loop and it forms a circuit. Right? So there is continuous electricity in this last pair. Now, if you have to send 1 to the other computer, I'll send a high voltage. If I have to send 0, I'll send a low voltage, right? This is known as signaling. That is just one way of signaling, or just one way of sending codes across one device to another device. There are various signalings that you use. This is just one example that I'm giving you, using high voltage for 1, low voltage for 0. There are various types of signaling. I just wanted you to understand how the data flows across the wire. Okay, so that is known as signaling. Just keep that in mind. Now, this Ethernet cable connected between the devices has 4 pairs of wires. The last pair forms a circuit, and the 1 and 3, 1 is used to send the data, 3 is used to receive the data. I have to check on that. I'll check and let you know. Okay, 1 and 3 are used to send the data. 5 and 7 are used to receive the data, or 4 and 7 are used to receive the data. I'll check on that before I confirm that. So this is how actually the data is transferred from one end to the other end. And also that is written in the physical layer protocols. What is the standard that we have to follow, right? And if you are connecting two same devices, right? If you are connecting two same devices, like a switch and a switch, then you have to use a crossover cable, right? So 1 and 3 are used to send the data, 4 and 7 used to receive the data. Here, 1 and 3 is receiving the data, 4 and 7 is sending the data. This is a straight through cable, right? Where you are sending on one, for example, this is 1. You're sending on 1 and this is receiving on 1. You're sending on 3 and this is receiving on 3. Here, you are receiving on 4 and you are receiving on 7. And this is sending on 4, this is sending on 7. This is straight through cable, which is between computers and switches. But if you are connecting the same devices, like a switch and a switch, then what happens? If you're sending on 1, it will receive on 4. If you're sending on 3, it will receive on 7. Here, 1 to send, 7 to send. So it will be the opposite. So for connecting same devices, don't worry, this is actually not something that they will question you in the exams, or they will, or something that in your organization you will, you'll need to know, so that you need to connect. Everything will be connected. You just have to work on the switches and routers, right? So this is just for your information, just to show you how it is connected and how the cables are made. I'm just giving you an example, right? If you want to connect the same cables, connect the same devices, like switch and a switch, router and a router, you use crossover cable. If you are connecting different devices, router and a switch, router and a switch, computer and a switch, you are using straight through cable. Straight through cable. Now in the cables also, we have some, first they found out Ethernet cable. It could support about 10 Mbps, right? Then they got fast Ethernet technology. They got fast Ethernet, which could support about 100 Mbps. Then they got gigabit Ethernet. It could support about 1 Gbps. Now we have 10 Gbps and more than that. So these are different types of technologies we have in cables, layer ones, and this is all defined in the physical layer, right? We are actually focusing on different layers. This is just, the extra information that I'm telling you. So to keep you, in the understanding mode of different layers, what it defines, why is it needed, why these physical layers rules are needed. For that, I'm just giving you an extra information. Now, the second layer is data link layer. Data link layer, which is known as layer 2. Now, there is a data 1010. When it goes to the data link layer of a PC, for example, a PC is getting it through a cable 1010. This data which a PC has to send from this PC to B, from A to B, always the data should be encapsulated, or it should be added in with an envelope of from and to address. But there are different types of addresses. What are those different types of addresses? Every computer has a network interface card to which you connect your cable, right? On that network interface card, you will have an address burned. That is known as MAC address, right? On that network interface card, right, it will look like this, and you will have an address burned. It is known as MAC address. Every computer who is sending this data has to put layer 2 header of source MAC, destination MAC. Source MAC is A. Let's say we don't know how the MAC address looks. For now, let's say A, destination is B. Right? This is what happens in the layer 2, data link layer. So it is always concerned with the MAC. Right? It is always concerned with the layer 2, and also it has something known as checksum or frame check sequence, FCS. What is frame check sequence? So for example, I have a computer to computer. Now it has some data. Now it has added source and destination. Now this data is going here. What if somebody here tries to alter the data by putting, something like this? So basically what this computer does, once it adds everything, layer 2 header and the data, it will calculate a mathematical formula. Let's say the output of the mathematical formula is 32. It will store that here in this field, right? Means on the data is like this. Now you added from address, which is your source MAC A, and 2. And you also add in that envelope, outer envelope, you say 32 number. Now the guy who receives it will again calculate the same mathematical formula If the number he gets is 32, then he thinks that, okay, nobody has done anything to my data, and he will accept it. Otherwise, he'll just drop. He'll just drop that frame. That is the reason we use something known as frame check sequence, right? Where it is used to check if the frame or the information has been altered or no, right? Now, which device works on this layer 2? That is what we were speaking of all this while. That is your switch. Your switch works on layer 2, means it does not read your data inside. The switch, whenever you send the information and in between the computers there is a switch, switch will see where you need to forward and just forwards it out on that port. How does the switch forward? We will look at it once we discuss about the OSI model complete layers. So what I do is, for today, I'll just keep it to this, the physical layer and the data link layer. I don't want to, bore you with more concepts on the first day itself. First, let me know if you were able to understand it till now. Was it easy to understand, or did you find any complications in understanding? Do you need a bit of slow moving than this, or are you fine with this?
Yes, so we are fine with this, sir.
All right.
We wanted to make notes regarding this, like how can we that helpful?
Don't worry. So all the sessions that you actually attend will be recorded and it will be in the portal and you can access it anytime. So it will take about a day or two to upload it in the cloud. The recordings to get uploaded in the cloud will take about a day or two, but you will have that in your profile and you can access it anytime.
Thanks for the update.
Sir, can you please repeat about that FCS only?
Yeah, sure. So for example, this is me. I am sending some information, right? Let's say I'm sending pin 5402 and I'm sending it from computer A to computer B. And this guy is expecting some data from me, but in the middle, there is an attacker or somebody who just wants to, spoil the data. He just wants to say 54023. Let's say he changed the data. But what this computer will do, just to avoid such scenarios, first it will see the data 5402. It will add source and destination, MAC address, that is the NIC card address of this port. NIC card address is nothing but your MAC address and the NIC card address of this port, and it will send it to a mathematical function. Okay, inside this maybe some algorithm is used. We don't need to worry about what algorithm and how it generates an output, right? We don't need to worry about that. For example, let's say here in the mathematical formula, it'll, in this algorithm, it will consider all this inside this and give you an output of 32. Don't worry about how it gives 32. Let's say it is using, for A, it is using 1. For B, it is using 2. And for 5, it is using, E. Let's say, right? 5 is 5, right? Then 0 plus 2. So it is adding everything. 8 plus 2, 10, right? Then 1 plus 0 or just 10. So output is 10. This is the simplest of example I'm giving, but it is not that way. Algorithms use many complicated things and give you a result out of that. It gave a result 32. Now I'm storing that 32 on my envelope. So for example, this is my data 5402, and upon that I'm adding an envelope upon this data. From address is A to address is B, and also on that envelope I'm writing on the back side or somewhere I'm writing 32. Now this data reaches this guy, who? The computer B. This guy also says, okay, he is the sender, I am the receiver, and the data is this one. Let me run the same through the same mathematical formula that he ran. Okay. Now, if I get 32, it matches with the one he put in the value on the envelope, then nobody has altered anything on the data that is being sent to me. If there is something, if I get 33, then no, this whole data was altered because he has put 32 on the packet and I'm getting 33 out of this. So it is not a correct data that I've received. It has been altered. Make sense? Did
Yes,
you
sir.
get it?
It's clear. Clear. Yes, sir.
Rahul sir, please repeat this again.
14.
No worries. We can actually go over it once we finish the OSI model and reach the layer 2. Right? So once we reach layer 2, we are talking about the header in a separate class. Means what all is there in layer 2 header. At that time, I can still again explain you what all in the layer 2 we have. What are the factors like frame check sequence, what is the source MAC address, destination MAC address. I'll explain it to you again. No worries. All right. That's all I got for today. Thank you so much, guys, for joining in. If you do not have any doubts, we can wind it.
Thank you, sir.
Thank you so much.
Thank you, everyone.
Thank, thank you, sir.
Thank you, sir.
Thank you.